Hello everyone. Let us now talk about today's Leetcode POTD, Leetcode 2064, minimized maximum of products distributed to any store. So, in this question, we are given with an integer n and quantities, an array named quantities. So, it's a zero indexed array, and now we need to distribute these quantities. That means where in this quantities array we are given with the number of uh, the amount of items we have. That means if the item is laptop or iPhone or a mic, then the number of laptops we are having, the quantity is stored in this array. That means every index is having a different type of product. So we are given with n, that is equal to maybe a 7 or 6 or 5. But if we take an example, n is equal to 6 and quantities is equal to 11 comma 6. That means we are given with two items which are having quantity of 11 and 6. Maybe it may be a laptop, uh, assume it as an F. So we are given with 11 laptops and 6 iPhones. So as we are having 6 stores, we need to divide them such a way that we are having a minimum of the maximum products or the quantity we are distributing. That means if we take two laptops here and three laptops here, three here again, and three laptops here again, and then here we are completed with the laptops as it combines with 11 laptops here, and then we have left with 6 iPhones. Now we can distribute them as 3 iPhones and 3 iPhones. And we are given with another example, n is equal to 7, and the quantities given are 15, 10, 10. So we are having 7 stores. These are the stores. So we are having 7 stores, and we need to divide. Let us think this is laptop, an iPhone, mic. We are having 11 laptops, 10 iPhones, and 10 mics. So we can divide this. We need to divide this such a way that we need to give a maximum number of products uh, to a store. That means we need to minimize the maximum number of products. Let us see how. Here we distribute 5 laptops for the first store, 5 laptops to the second store, 5 laptops to the another one, and 5 iPhones, 5 iPhones. So here we are having 10, sorry, 5 mics, 5 mics, 10 mics, 10 iPhones, 15 laptops. So if we think clearly, we can get to the approach of binary search. We need to think that every time every time if the question states that minimum of maximum or maximum of minimum, then blindly we can go with the binary search. But how can we use binary search here? So to know that, we need to know what is the element x, what is the element x which we need to divide for given items to a store. That means let us think let us think in a different way. Let us think, uh, The last example 15, 10, and 10. The maximum items we can give to any store is 15. That means we can give all the items to only one store. We are assuming like that. And minimum items we can give to any store is one. So any item, the number of items we need to give to any store will be in this middle. The optimal will be in this middle, in the middle of this range, or maybe 1 or 15. Maybe it can be 1 or 15. That means here it is the low and here it is the high, and we need to calculate the mid, which is optimal one. So let us do it. 1 and 15. Here the mid is 15 plus 1 by 2 is 8. Now mid is 8. So we have 15, 10, 10. How can we divide this with uh, with 8 items for each store? 15 laptops to be divided with uh, with each store having 8 or less than 8. So to do that, we need to divide 15 with 8. 8 ones are 8 and 7. We get a point. So we are left with 7 laptops here. So to divide 8 laptops or less than 8 laptops, we need we need two. We need two stores. So we use a function called seal. So what is a seal means, it is clearly the upper position or the upper value when we divide with a number. So 15 by 8 will give you 1 point something maybe. Then the result will be 2. And then 10 by 8, it will give us 2. 10 by 8, it will give us 2. So uh, all this will be is equal to 6, which is less than or is equal to 7. Now, we need to go back. We need to go back and make our high is equal to mid minus 1. And then, if we do that, 1 and 7. Here we find another mid, and then we make another, if we get an x value, or here the x value is the number of items we are distributing to the stores. 2 plus 2 plus 2 is equal to 6. If we get to the optimal one, we get 3 plus 2 plus 2. Here it is 7. So our x is 7. If it is less than or equal to, we need to make I is equal to mid minus 1. But what if we are having x is greater than 7? That means x is greater than n. Then we will need to make low is equal to mid minus 1. And remember to stop only when low is greater than high. That means the while condition will be while condition will be low is less than or is equal to high, and low is equal to 1, and high is the maximum element from quantities. And then we need to make sure we are having a result, that is the maximum number of items we are giving to a store. So the count, it is if we see it as x, the number of items given for all stores. And then min is equal to low plus high minus low by 2. Iterate the quantities, and then the number of stores we require is seal of float of it by float mid. As I mentioned before, 15 by 8, IT by mid, IT by mid. It is iteration. IT auto IT is used for iterating loops. Auto is a variable, or it is a automatic initialization for any type of array. It may be an ordered map or a set or anything else. Instead of using mid, int or string, we use auto, and then uh, count will be increased by stores required. As I mentioned before, x, you can think it as x. If count is less than or is equal to n, result will be our mid. And here it is the maximum, the number minimized maximum number of products or items which are given to a store. And then if the count is less than or is equal to n, or x is less than or is equal to n, we make high is equal to mid minus 1. Else, as if it is not satisfied, count will be greater than n, then we need to use less amount of items to distribute this to the stores. That means we come back, we make our mid to be low, sorry, to be high. Low is equal to mid plus 1, and then we return our result here. Thank you.